All right, so we are doing section 10.2. 10.1 is about conversions from radians to degrees and degrees to radians, which I don't know if we're going to actually touch on that, but not today. But 10.2 is ratios of trig functions, and then we're going to do solving a triangle. So let's talk about the ratios first. Okay, so there are three main trig functions that you guys need to know about. Okay. The sine, the cosine, and the tangent function. So let me put this right here. 3 trig, and that's perfect. All right, so sorry about that. Pen just stopped working here. Hold on, let me. So 3 trigonometric functions. Now there's 6 of them, but we're only going to deal with 3 of them. Okay, so 3 trigonometric functions. And those are all, the 3 I'm going to talk to you guys about are all buttons on the calculator. You guys should be able to see all the buttons say, well, some people say sin, cos, and tan. But it's sine, cosine, tangent. But they are 3 buttons pretty much right in the middle of your calculator towards the right side sometimes towards the left side, depending on what your calculator looks like. But we do have the sine function, okay, which they abbreviate as sin. Okay, we have the cosine function, which gets abbreviated as cos, all right, cosine. And then we have the tangent function, which they'll write that as tan. Okay, so we have sine, cosine, and tangent function. Now, we're going to be using these things to try to figure out values of triangles and things like that. But before we do that, I got to discuss their ratios. Okay, what do they mean in terms of a triangle? So, let me draw a triangle here for us really quickly. Now, we are going to deal with right triangles. So, right triangles are triangles with a right angle on it. Okay, so there's a right angle. And we'll call this our X, our Y, and our Z. Okay, so we're going to call that our X, our Y, and our Z. And I'm going to call this our angle theta. Theta is like a 0 with a little line across it. Okay, that's a Greek letter. Okay, so theta. We usually use theta for angles. So here's our definitions that they're going to want us to do. And I'm going to write them out, and then we're going to talk about another way to see it. But usually, this is the way it's written out at first. Sine of theta is equal to opposite over hypotenuse. Oops. So opposite over hypotenuse. Okay. Now what they mean by opposite over hypotenuse is they're talking about what is the opposite side of that angle. What is the hypotenuse based on that triangle? Okay. I don't know if you guys remember when you did this in geometry, but your hypotenuse in a triangle is the longest side. Okay. The longest side for us would be Z. Okay, because that's opposite the 90-degree angle. Okay, so Z would be our hypotenuse. The opposite side of the angle basically gets shot this way. This is the opposite of that angle. Opposite side. Because notice X is touching the angle. Z is touching the angle. The opposite side does not touch the angle. Okay, so my Y value is my opposite side. So we'll write this as Y over Z. Okay, some people actually might call it R. Some people call it ABC instead of XYZ. It really doesn't matter, but it's that. Okay, XYZ or XYR or ABC. Those are the letters that they use for those triangles. So we're just using X, Y, and Z. So your sine of theta is going to be your Y value, whatever that is, divided by, divided by your Z value. Okay. Now, cosine of theta is adjacent over hypotenuse. The adjacent side over the hypotenuse side. Now we know the hypotenuse has to be the longest side, so our z value. Okay? Adjacent by definition means next to. There's two sides next to the angle, the x and the z. Okay? But the z is already called the hypotenuse. So that means x has to be the adjacent side. Okay? Right now we'll label all that stuff. But x over z. So sine is opposite over hypotenuse. The opposite side would be y. The hypotenuse is always going to be the longest side, which is going to be z. Okay. Cosine of theta is adjacent over hypotenuse. X and z are both adjacent to the angle. They're both next to it, right? Like this angle is being touched by this side and by that side. Okay. So both sides are being touched by that angle, but one of those sides already has a name. That's our hypotenuse, the z value. So the other one has to be the one we call next to, right? The adjacent side, the x value. So x over z. And then tangent of theta is opposite over adjacent. Excuse me, I gotta drink some water here. Opposite over adjacent. So our opposite side is going to be y, because that's the side that doesn't touch the angle. And then our adjacent side is going to be x. So just to kind of label this based on this information. Adjacent, opposite, and hypotenuse according to that angle. Okay, if the angle changes and it goes to the top one, then things can change as well. But according to this picture, there's my opposite, adjacent, and hypotenuse. And then the thing that usually you guys learned from geometry, at least I think you guys did. So if you take these letters, okay, and write them out. This is a lot of times what they teach you in geometry. They'll tell you, remember that, SOHCAHTOA, right? Try to remember that acronym there. Because that basically tells you the SO means sine is opposite over hypotenuse. The CA is cosine is adjacent over hypotenuse. And the TOA is tangent is opposite over adjacent, right? It's just a nice little way of saying it where you can memorize all three of these terms. All right? So this is kind of like the intro to what we're going to be doing today. The rest of it is done either just by vision and you just kind of pick your information, or else you're going to have to use a calculator to do it. Okay, so we'll get to that. But the most important part is the introduction of this. So making sure how to identify sine, cosine, and tangent. So the first examples we're going to do, we're going to just identify the pieces. Okay, that's called the ratio values. Okay, so these are all the ratio values, what we're doing. Ratio meaning fractions. Okay, so we're going to do all the ratio values first, and then we're going to do the calculator part next. So let me show you some examples of what you're going to be doing at first. So this is example number 1. And this says find the value of the trig function. So find the value of the trig function. So we'll try doing at least 3 examples, one for sine, one for cosine, one for tangent. So here we go. We're going to find sine of theta first. And I'll draw a triangle that looks like this. And we'll put 4, 3, and 5, like that. Find the value of the trig function. So they want me to solve for sine of theta. Now I know sine of theta is going to be a fraction, okay? If you look at all the definitions, they were all fractions, okay? So I know it's going to be a fraction. But according to the definition, sine of theta, so theta is my angle, this little angle that's right here, right? There's sine of theta. I got to figure out what's the opposite side of it, okay? So what's the opposite side of the angle? In other words, what side does not touch the angle? 4, right? 4 is not touching the angle at all. Notice this angle, if you kind of want to do it this way, it's up to you. But you see the little arc I put around the theta? You can put little arrows if you want. So it shows you that's the two sides that are being touched by that angle. Okay? Opposite side does not touch the angle. So 4 is the opposite side. Now, the hypotenuse is what's supposed to go on the bottom, right? Opposite over hypotenuse, SOH, right? Opposite is 4, hypotenuse is on the bottom. It's supposed to be your longest side. Which side is your longest side? The 5, right? 3, 4, so 5. This is the answer that they want. That's it. You don't have to do anything with it. Just leave it alone. Okay? So sine of theta is 4 over 5. So you just have to identify them and put them in a fraction. So that was a sine problem. Let's do a cosine problem. So there's my triangle, okay? Cosine of theta, we're trying to figure out cosine of theta. There's my right triangle. Again, it's called a right triangle because it has a 90-degree angle in it, okay? And we're trying to figure out the ratio for cosine of theta. All right, so according to the definition, cosine is adjacent over hypotenuse, okay? Now 12 is my opposite side because 12 is not touching the angle. So since I'm looking for my adjacent side, it's either 5 or 13. Which one is the adjacent side? The 5. Why is the 5 not the 13 the adjacent side? Anybody tell me, why is 5 considered the adjacent side? Because that's right. Why is that one considered the adjacent side, not 13, which is also adjacent? Because it's the what? The hypotenuse. And we know it's the hypotenuse because it's the what? It's the longest side. So the longest side is automatically the hypotenuse. So you don't have to wonder if the hypotenuse is the opposite or the adjacent. No, the hypotenuse is the hypotenuse, right? So the longest side is 13. So the only other side that's next to the angle is 5. So 5 has to be my adjacent. And since it's adjacent over hypotenuse, that's going to be 13. And there's your trig ratio. Cosine of theta is equal to 5 over 13. Adjacent over hypotenuse. Do you guys remember doing this last year? Okay. Again, this is just a quick review that they're wanting you guys to do just to get you prepped for the CASP exam that's coming up. So, all right, last one that we're going to do here, tangent of theta, just doing these ratio values. So let's do one that looks like this. I don't know. Let's try 6. All right, so according to the definition for tangent, right, that's the TOA part, right? TOA, meaning opposite and adjacent, right? Opposite over adjacent. So there's going to be a fraction as usual. What is my opposite side according to this angle? And actually, I forgot to put my 90 degree. I'm sorry, 90 degrees right here. The 6 is the opposite side because the 6 isn't touching the angle, right? So 6 is opposite. And what's my adjacent? 8, right? It could be 10 or 8, but 10 is the longest side, so then we don't want to use that as adjacent. That'll be my hypotenuse, so it's going to be the 8. Now, in this case, you are going to want to reduce. So this will be 3/4. Okay, so tangent of theta is 3/4. So, I mean, you guys have 6 questions like this to do for homework. They're not hard. It's just identify the pieces, okay? They're going to be fully labeled for you. All you got to do is write them as a fraction. And if you have to simplify by reducing, then reduce. But in the most cases, it's just straightforward. All right? So that's going to be part of your homework. Now, the other part of the homework, this is the part where the calculators come in, is where they're going to want you to figure out measurements to sides. Okay? So let me give you example number 2 here. So again, this is where your calculator is going to come in handy. If you don't have one, there's some up here. You can come and grab one. So find the measure of the side indicated, or of the indicated side. Find the measure of the indicated side. All right, so here we go, part A. So here's our first triangle, x, 3. Now this is going to have something that we haven't seen yet, and I'm going to put them in a different color here. They're putting vertex names. So the vertex has a name now, A, B, and C. But they did give us an angle here, 37.1 degrees. Okay, 37.1 degrees. I'll kind of zoom in here so you guys can see it. Okay, so they're calling the vertices ABC. So a lot of times in geometry they call this triangle ABC, right? Because it has those 3 letters as the vertices. So they want us to solve for x. Okay. Now I have an angle of 37.1. That's my theta. I have a 3 on the AC side, right? Is that 3 called my opposite or my adjacent or my hypotenuse? That's opposite, right? Because 3 is not touching the angle, right? That side is not touching the angle. So I'm going to write right here, opposite. Okay. What is x? Is that my adjacent or is that my hypotenuse side? Hypotenuse. Okay, and you might say, well, I don't know the length, so how do I know it's the longest one? By definition from geometry, they taught you in geometry that the side opposite the 90-degree angle, in other words, opposite the 90 degree, that's always your hypotenuse. So I know that this is my hypotenuse. All right. So what trig function deals with opposite and hypotenuse? The sine function, right? So sine of 37.1 degrees is 3 over x, opposite over hypotenuse. Now, they are going to want us to round this stuff to the nearest tenth. So let's figure out what sine of 37.1 is. So now you're going to get your calculator, right? And you're going to do sine of 37.1. Make sure you're in degree mode, which we talked about earlier. When I hit enter, 0.603, that's what I get. Okay, let me just put this right here, like kind of like some side work here. Sine of 37.1 degrees is 0.603. But on the instructions in your homework, they're going to say round to the nearest tenth. So this is basically 0.6. Okay? So 0.6. So let me put that right here. 0.6 is equal to 3 over x. All right, well, I got to solve for x. But right now it's in the denominator. So what I'm going to do is I'm going to move it over to the other side by multiplying it, okay? So I get 0.6x equal to 3. Now to solve for x, all I need to do is divide both sides by 0.6. And that'll get x all by itself. So 3 divided by 0.6 is 5. So there's my answer. There's my answer for that problem, okay? So they gave me an opposite side. They wanted me to solve the hypotenuse side. They gave me an angle. So I decided to use a sine function, okay? The sine function, because sine deals with opposite and hypotenuse, okay? I set it up. Once I set it up, I used my calculator to figure out what sine of 37.1 was, right? So I just punched it in. I rounded it to the nearest tenth because that's what they wanted us to do. And then I just solved and I got x equal to 5. Okay, so let's do a couple more of these, hopefully one with the cosine, one with the tangent, so you can see each one of them. So just give me a little bit of time while I look at the problems they're giving you so I can tell which ones they're going to want you to do. So that's another sine problem here. All right, let's try this one. There's an 8 here, an x here, and a 36 degrees there. They did label the vertices again. They called it A, B, and C like that. But it doesn't really matter that they labeled them. It's not a big deal. I'm just writing them out for us. Okay, so it looks like this. Whoops, sorry about that. So think about this one. They gave me an angle of 36. They gave me an 8 and an x, right? Which trig function am I going to use? Sine, cosine, or tangent? Cosine. Yeah, because if you're wondering, well, how do I know it's cosine? You notice how the angle is actually touching both sides, right? The angle's touching 8, the angle's touching 36, right? If you're wondering what I mean by that, look, remember I draw the little arrows, right? So you can see that it's actually touching both sides, right? When it's touching both sides, that's a cosine function because one of them has to be adjacent, the other one has to be your hypotenuse. The opposite side would be side AC, and that has nothing on it. So there's no, since the opposite side is part of sine and tangent, right? By definition, sine is opposite over hypotenuse, tangent is opposite over adjacent. There is no opposite, so it has to be cosine. So cosine of 36 degrees is adjacent over hypotenuse. So what's my adjacent side, x or 8? X, right? Because 8 is opposite the 90-degree angle. That's my hypotenuse. This will be x over 8. All right? Now you can multiply cosine, or not multiply, you can get cosine of 36 on your calculator. So let's do that. Cosine of 36 comes out to 0. I'm going to do it right here on the side. Cosine of 36 degrees is 0.809016, etc., which is approximately 0.8 in terms of tenths, right? So I'm going to call it 0.8. And to solve for x, I just got to multiply by 8, and I'm done. So let's multiply the 8 over here. So that means x is equal to 0.8 times 8, which is, for me, it says 32 over 5. Is that what you guys got? 32 over 5, which is fine. But if they want an actual decimal, remember, there's a little button on these things that looks like this for most of you guys. Some of you guys have this button, SD button. Some of you guys may have a button that just has 2 arrows like this. okay? And if you don't have either of those, ask me once we're done, okay? But your answer, when I press it, comes out to 6.4. Okay? And then if you press it again, that same button, it'll take it back to a fraction. So that changes things from fractions to decimals, back and forth, okay? So there's my answer. So let's do one more that's considered a tangent function. I'm checking to see if we have one. Yeah, we do right here. So one more of these things, and then I'll let you guys kind of work on it. So the triangle looks like this. This is x. This is 68 degrees, 7.1. This is A, B, and C. Usually the letter C is always reserved for the hypotenuse, just so you guys know. But sometimes it's not. All right, now I know I told you that this is going to be the tangent function, but if you look closely, the angle, the letter is there at the bottom left corner for B, right? It's there. X is the opposite to that angle because it's not touching the angle. So that's opposite. So I know I have an opposite side, so it's either tangent or sine, one of those two. But then I look, and then I have the 7.1 right there. 7.1, and if you look at side AB, that really long one, right? 7.1 is not as long as side AB. That means side AB is my hypotenuse. That means that BC is my adjacent side, okay? So this is opposite, this is adjacent, okay? So that's TOA, right? Tangent is opposite over adjacent, right? So tangent of my angle, 68 degrees, is opposite. And I'm getting, so tangent 68 is equal to x over 7.1. Find tangent of 68 on your calculator. You're going to get approximately tangent 68 degrees is 2.475086, etc., which is approximately 2.5. So 2.5 is equal to x over 7.1. Just multiply 2.5 times 7.1, and you'll get 17.8. And that's what you guys have for homework.